Hello everybody. I'm tired, and so for once I'm not going to be screaming erratically at you. I'm just going to talk to you normally and work you through these problems in a calm and controlled manner. So let's do problem number 1. A quadratic function with a leading coefficient of 1 has a solution at x equals 1 minus 2i. We need two pieces of information to be able to do this problem. Piece of information number 1 is that if we have a solution at x equals 1 minus 2i, we also have a solution at x equals 1 plus 2i, the complex conjugate of the other complex solution. Complex solutions always occur in conjugate pairs. What that means is the imaginary term has the opposite sign, the other term has the same sign. So that is thing 1 you need to know. Thing 2 that you need to know is if you have a solution, you will always have a factor at x minus that solution, which means we will have a factor at x minus this entire solution. So think about distributing a minus into that, so minus 1 and plus 2i. And we'll have another factor at x minus distributing into this entire thing, so still minus 1, but now minus 2i. So again, look at how that works out. Kind of similar idea here. The real part sign is the same. The imaginary part sign is changed. And so now, what do we do from here? Well, since we're told the leading coefficient of 1, that's just like saying there's a 1 right there. And this is our equation. Now I'm not going to write that 1 because it doesn't do anything. We don't need it. So we have our equation. But we want to write this as a more normal looking quadratic, and so we need to multiply it out. We need to expand it. So in doing so, we will take x times x to get x squared. We will take x times negative 1 to get negative x. We will take x times negative 2i to get negative 2xi. And then go to your next term and distribute that to each piece. So negative 1 times x is another negative x. Negative 1 times negative 1 is a positive 1. Negative 1 times negative 2i is a positive 2i. Now let's do the last one. Positive 2i times x is a positive 2xi. Positive 2i times negative 1 is a negative 2i. And a positive 2i times a negative 2i is a negative 4i squared. Now this may look gross, but a lot of stuff cancels out and we're only left with a few pieces. Look at this negative 2xi. We'll cancel it with this positive 2xi right there. This positive 2i will cancel it with that negative 2i. And what we'll be left with is an x squared. We will be left with a minus x right there and a second minus x right there. And then we'll be left with a real number, 1, and another real number, negative 4i squared. Wait a minute, that's not real. Yeah, it is. Remember that I squared equals negative 1, so negative 4i squared equals negative 4 times negative 1. So that number is really just a positive 4. And so we get our polynomial y equals x squared minus 2x plus 4. And that is our polynomial in standard form. Or at least it would be if I could do math. 1 plus 4 is 5. So there you go. X squared minus 2x plus 5. Now, some people like to use a grid to keep it straight. Go ahead and do that if you like to. It's going to work out to the exact same thing as we got a moment ago. All of the same pieces are going to cancel out again, and we will be in the same situation that we were a moment ago. But important things to notice is that all of the imaginary stuff cancels away. The I squared makes that a positive 4 at the end. And so we're left with x squared minus 2x plus 5 once again. Now, let's think about the factors we started with. We started with this factor of x minus 2 minus 2i. Whoa. X minus lies. sorry, I'm tired, told you. X minus 1 minus 2i, and x minus 1 plus 2i. If you're feeling savvy, you can go straight to this standard form equation by noticing that we will get an x squared from that bit. We will get double that many x's, minus 2x, right? Because we'll get that minus x right there, and we'll also get that minus x right there. And then in terms of the real part we get, well, we get that minus 1 squared, so we get a 1, and we get that 2 squared, a 4, so we get our 5. And it's pretty much always going to work out that way. If you want to think about how that works, you're welcome to. But we have our standard form, ax squared plus bx plus c, and we want to write this in vertex form, so that is completing the square. So to complete the square, we are going to factor this. We're going to write it as a completed square, so x squared minus 2x completed will become x minus 1 squared. Where did that minus 1 came from? It is half of that middle term right there, that minus 2. So x minus 1 squared. We still have our plus 5, but we need to adjust this equation because x minus 1 squared is x squared minus 2x plus 1. So we have added 1 in that completed square, so we need to subtract 1 like that. And so we get y equals x minus 1 quantity squared plus 4. And again, if you look at what we started with, which was x minus 1 minus 2i and x minus 1 plus 2i, we ended up with an x minus 1 right here, and we ended up with a 2 squared right there. Things to notice. So we want to graph this, which shouldn't be too crazy. So boom, boom. It is shifted right 1, it is shifted up 1, 2, 3, 4, and I can graph it from there, knowing what we've done oodles of times.